How do you reliably find, segment, and track every instance of any concept across large image and video collections using simple prompts? Meta AI team has just released Meta Segment Anything Model 3 or SAM3, an open-sourced unified foundation model for promptable segmentation in images and videos that operates directly on visual concepts instead of only pixels. It detects, segments, and tracks objects from both text prompts and visual prompts such as points, boxes, and masks. Compared with SAM2, SAM3 can exhaustively find all instances of an open vocabulary concept, for example, every red baseball cap in a long video, using a single model. Earlier, SAM models focused on interactive segmentation. A user clicked or drew a box, and the model produced a single mask. That workflow did not scale to tasks where a system must find all instances of a concept across large image or video collections. SAM3 formalizes Promptable Concept Segmentation (PCS), which takes concept prompts and returns instance masks and stable identities for every matching object in images and videos. Concept prompts combine short noun phrases with visual exemplars. The model supports detailed phrases such as yellow school bus or player in red, and can also use exemplar crops as positive or negative examples. Text prompts describe the concept, while exemplar crops help disambiguate fine-grained visual differences. SAM3 can also be used as a vision tool inside multimodal large language models that generate longer referring expressions and then call SAM3 with distilled concept prompts. The SAM3 model has 848 million parameters and consists of a detector and a tracker that share a single vision encoder. The detector is a DETR-based architecture that is conditioned on three inputs: text prompts, geometric prompts, and image exemplars. This separates the core image representation from the prompting interfaces and lets the same backbone serve many segmentation tasks. A key change in SAM3 is the presence token. This component predicts whether each candidate box or mask actually corresponds to the requested concept. It is especially important when the text prompts describe related entities, such as a player in white and a player in red. The presence token reduces confusion between such prompts and improves open vocabulary precision. Recognition, meaning classifying a candidate as the concept, is decoupled from localization, meaning predicting the box and mask shape. For video, SAM3 reuses the transformer encoder decoder tracker from SAM2 but connects it tightly to the new detector. The tracker propagates instance identities across frames and supports interactive refinement. The decoupled detector and tracker design minimizes task interference, scales cleanly with more data and concepts, and still exposes an interactive interface similar to earlier segment anything models for point-based refinement. To train and evaluate promptable concept segmentation (PCS), Meta introduces the Segment Anything with Concepts (SACO) family of datasets and benchmarks. The Segment Anything with Concepts benchmark contains 270,000 unique concepts, which is more than 50 times the number of concepts in previous open vocabulary segmentation benchmarks. Every image or video is paired with noun phrases and dense instance masks for all objects that match each phrase, including negative prompts where no objects should match. The associated data engine has automatically annotated more than 4 million unique concepts, which makes Segment Anything with Concepts the largest high-quality open vocabulary segmentation corpus as mentioned by Meta. The engine combines large ontologies with automated checks and supports hard negative mining. For example, phrases that are visually similar but semantically distinct. This scale is essential for learning a model that can respond robustly to diverse text prompts in real-world scenes. On the Segment Anything with Concepts image benchmarks, SAM3 reaches between 75% and 80% of human performance measured with the CGF1 metric. Competing systems such as OWLV2, DynoX, and Gemini 2.5 lag significantly behind. For example, on SACO Gold box detection, SAM3 reports classification gated F1 of 55.7, while OWLV2 reaches 24.5, Dino X reaches 22.5, and Gemini 2.5 reaches 14.4. This shows that a single unified model can outperform specialized detectors on open vocabulary segmentation. In videos, SAM3 is evaluated on SAV, YT Temporal 1B, Smart Classes, LVVIS, and Burst. On SAV test, it reaches 30.3 classification gated F1 and 58.0 POTA. On YT Temporal 1B test, it reaches 50.8 classification gated F1 and 69.9 POTA. On Smart Classes test, it reaches 36.4 classification gated F1 and 63.6 POTA, while on LVVIS and Burst, it reaches 36.3 MAP and 44.5 HOTA respectively. These results confirm that a single architecture can handle both image PCS and long horizon video tracking.